Okay, let's finish up this example here. I did A and B in the previous video. I just want to finish up C. So C part, determine how many times you can expect him to be in a bad mood over the 10 days. And this is the easier of the questions because once you've identified it, we already identified in A part that this is a binomial distribution, which means that the corresponding formula for expected value is just n times p. We're looking at 10 trials or 10 days, and we said that the probability of success was 0.05. So now it's just a simple calculation, 0.05 times 10, so 0.5. So what that means is we can't even expect one day that he'd be in a bad mood. So therefore, not even one day in the 10. What that tells me is that 0.05, in order to get it up to a 1, it would have to be multiplied by 2. It'd have to be twice as big. You can't change the probability of success. What you can change is the number of trials, so that would have to be doubled. So that means we would have had to take this study over 4 weeks, over 20 school days to even get it to 1. So over a 2-week period, we can't even expect Mr. Agar to be in a bad mood. So there we go. So there is an example using the binomial distribution. So I have one last example I want to do with this, and it's a little bit different than that one. So we're looking at a multiple choice test. There are 5 questions on the multiple choice test. Each question has 4 answers, so A, B, C, D. If you guess at each question because you did not study, not that that's any of you that are watching the video, but some are out there that do that. Okay, what are the following? Determine the following. So, is this a binomial distribution? So some of you are going to be saying, I don't think so, but I'll explain why in fact it is. So identical trials. So just going through my checklist, maybe not in order. Are there identical trials? Yeah, each multiple choice is A through D, and it's going to be independent. Because whatever you answered on the previous one won't help you on the next one. So they're identical, they're independent of each other. If I didn't study, I have a 1 in 4 chance of each one. So same probability of success. All right. And identical trials, independent events, same probability of success, and I forget the 4th one, but you get the gist of it. So that is a binomial distribution. So A part. If you look at A part, it says what's the probability that you pass? Well, let's just go down here again. We know it's a Bernoulli, so we know that there are 5 multiple choice questions on this test, and I keep it small, and you'll see why in a second. Probability of success. There's only one correct answer, unless you're in a psychology course, then there's probably more than one. Let's just pick the best one. But in this case, there is one correct answer, so it's a 1/4 chance of success. And the chance of failure then, even though there are 3 other options, those 3 options are all failure, so there's 3/4 of a chance of failure here. So we have N, P, and Q. Probability pass. So as soon as I see this, that means that this is the same as at least 3. So that means that I have a couple of choices here, and I'm looking at the later questions. How many questions can you expect to get correct? Okay, you can decide whether you want to do this and create the table, or whether you want to do it out in long. So in this case, I'm going to do it out in long. So the probability that you pass, that means you got 3 correct, or 4 correct, or 5 correct. So that means that I'm going to have to plug in and solve these 3 probabilities. So starting it off here, 5, choose 3, 1/4 to the 3, 3/4, and it's got to be 5 take away 3, so it'd be 2. The next one would be 5, choose 4, 1/4 to the 4th, 3/4 to the 1, plus 5, choose none, 1/4 to the 5, 3/4 to the 0. So now we need to go ahead and calculate that to determine the probability of getting at least 3, which means that we passed this particular test. So let's go ahead and calculate. And the calculator tells me that it is a 0.103. So therefore, you have a 10.3% chance of passing simply by guessing. It's not very good. So even on a 5-question multiple choice, so just think if there was more than 5 multiple choice questions, say there was 10, 15, 20, yeah, it's only going to go downhill from there. So highly recommended studying for tests. All right. What's the probability you get perfect? Well, it's really part of our answer already. Probability of getting perfect occurs when our random variable is equal to 5. So we're just simply going to take that last term, that one right there, and that is what we are trying to find. So what is the probability of getting perfect? So putting that through the calculator, 5 times 0.25 to the 5th, I get something very, very, very small. And as I work on decimal, 0.00098. So therefore, you have a 0. I'm going to move the decimal place 2 over 0.98. So not even a 0.1% chance of getting perfect. So you have a 0.098% chance of getting perfect. Now some of you are wondering, it seems really, really low when I think back to getting 3 heads, for example. Remember with flipping a coin, there's only 2 outcomes here, so there's only a 50-50 chance of each event occurring. Here, we're talking about a 1/4, 3/4 split, so 25 versus 75% chance. Because you have 4 possible answers to choose from in 5 questions, it makes it tough. If I had more answers, if it was A through E, your probability would also drop. Okay? And the final question, how many questions could you expect to get correct? So because we already have defined this to be a binomial solution, it's n times p. So 5 trials, 1/4. So when you multiply that through, you get 5/4 or 1.25. So therefore, you can expect to get 1 question correct. You can't say 0.25. No such thing on multiple choice. It's got to be rounded to the nearest whole number. Oh, 1 question correct. All right. So, a couple of things here. First of all, you need to be able to identify a binomial distribution. So there are your 4 checks. So please make sure those 4 checks are on your cheat sheet. Make sure that your 2 formulas, probability and expected value, makes it onto your cheat sheet. And then be very, very careful or wary of the at least. So this is an at least question. At least 3 are correct versus an exact value. 2 different approaches. All right. If you have any questions with the homework, you know where to find me. There you go. Good luck.